Hey everybody, Mr. Mack coming at you with 1.6 practice here on midpoints and bisectors. So let's jump right into it here. Number one, show the congruent symbols on the figure with the givens. Well, we've got angle A is congruent to angle C, so I can show my arc symbol congruence just like that. I got angle B is congruent to angle D. So this is a different pair, so we'll use double hash marks to indicate this pair of congruency. Segment AB is congruent to segment CD. So this line segment is congruent to that one. We'll do singles, and then the last pair, segment AD, is congruent to BC. That's perfect. That's exactly what I'm looking for right there. Okay, next one. Is N the midpoint of segment LM? Prove it. So we're given LN is 6.7, NM is unknown, but LM is 14.4. So if N is the midpoint, that means that half of LM should be 6.7. So let's see, if we take 14.4 and we take half, we end up getting 7.2. Well, 7.2 is the value that this segment would have to be and this one, and clearly ln is 6.7, so 6.7 is not equal to 7.2. Therefore, okay, that's our therefore symbol, n is not the midpoint. Okay, the other thing I could have done was find what the actual value of nm is by subtracting 6.7 to 14.4, and we would have seen that these two values aren't equal. So there's a couple of ways to do this problem. If segment OP is the angle bisector of angle SOT, and the measure of ROT is 115, what is the measure of SOP and POT? Okay, so why don't we label this measure? ROT is 115. We know that these two angles are congruent, because OP is a bisector. And so can't we can find angle SOT right here by taking 115 and subtracting 53. That would be the angle of SOT. And let's see. We've got 2 and then 6, so this would be 62 degrees. So the measure of angle SOT is 62. And because this bisects, we know that angle SOP is going to be half of 62, which is 31 degrees. So this is 31 and this is 31. And so I've got SOT, so I've got SOP is 31, and POT, these are both 31 degrees. So angle POT all right, next one. Given the measure of angle JHO is 90, JHO, so this angle right here, that's 90. Measure of IOH is 21, we got that. We know that KH is an angle bisector. Okay, so we know these are congruent. And we need to find the measure of KHI. KHI. Okay, I'm looking for this angle right here. All right, so we know, I mean, there's a couple of ways we could do this, right? We could say, okay, this is unknown. I can call this X, right? Because these are congruent, I can also call this X. So we could say, okay, x plus 21, I'm thinking my angle addition here, all add up to 90. And so I've got 2x plus 21 equals 90. And I could take 21 away from 90, and that gives me, what does that give me? 69. And then I take half of 69, and that's going to be 34.5 degrees. So the measure of angle KHI is 34.5. Okay. Next set, we have this figure right over here, and with all kinds of congruent symbols all over it. So what is the angle bisector of angle TPR? TPR, so what bisects TPR? Well, it's this segment right here with these 3 points, collinear V, P, and S. So we could say any one of those points. We could say, how about segment VS? Works for that. We could have also said segment SV. That's also fine, right? Or even if you wanted to say segment PS, that technically also bisects P to S or SP or VP. P is the midpoint of which two segments? Okay, so we can see because of these congruent symbols here, here and here, that VS is a segment with P at the midpoint, and also QT. So we're asking for segments, so please write the segment symbol like we know how to do. What is measure of angle QPR? QPR, well, we see right here, it's 90. Symbol right there for 90 degrees. What is the measure of angle TPS? TPS, all right, well, if this is 90, that means this angle over here is 90, because this makes a straight angle. And if we cut a 90 in half, we get 45 degrees. How does segment VS relate to QT? Well, VS cuts QT at P, and P is a midpoint of QT. So we can say that it bisects. Or it is a bisector of QT. How does QT relate to VS? Okay, let's kind of switch the wording on it. Well, because of these congruent symbols here, we know P is also the midpoint of VS, so it is a bisector. So they bisect each other. So is segment PU a bisector? Yeah, because P is the midpoint of these two segments again, okay? Same ones as we just saw in 9 and 10. So yes, it is a bisector of VS and QT. And what is the measure of angle QPV for number 12? QPV, we know these are all congruent. We already said that this one was 45 earlier, right? So if that's 45, that's 45. This angle is 45. QPV is 45 degrees. All right. Let's do some algebra. So we're going to write some equations and solve. Before we do that, let's recognize some symbols here. This symbol right here is the degree symbol, and it refers to an angle. So this is an angle right here. This expression, this algebraic expression, is referring to an angle. And if we look at y, these y terms right here, there is no angle symbol. It's just labeled, not inside an angle, but it's labeled in the middle of a segment. This is a segment length right here. So we see these two congruent symbols on this segment. We know that these are both equal. So I can say that 4y minus 19 on this congruent segment is congruent to the y plus 23 on this congruent segment. And then we're going to solve for y. So how about we get our y's together, and I add 19 to the other side. So 4y minus y is 3y, and 23 plus 19 is 42. And then divide 3 to both sides, and I get y equals 14. I could substitute that back in. Let's see, 14 plus 23. So this side length right here would be 37. And then this one right here, 14 times 4 is 64 minus 1964. Let's think about this. So 4 times 14 is 6. Sorry, I was off. 56. I was thinking, yeah, that doesn't quite work. 56 minus 19. Yeah, there we go. That's 37. Right? So that's our 37 there. Cool. I think I'm going to get rid of that because that looks messy. Okay, so we have this. I'll put in parentheses. That's 37, and this is 37. And now we got to get solve for x here and write an equation. So we know that this is 90, and these two are being bisected by this segment. So these have to be both 45. So the easiest equation to write here is just 2x plus 27 equals 45. And now we got to solve for x. I'm going to subtract 27 to both sides. 2x equals, let's see, what do we get here? 8, and then 3, 18, and then divide by 2. So we get x equals 9. So if I substitute 9 back in here, I should get 45, right? So 2 times 9 plus 27 better be equal to 45. And so 18 plus 27, that in fact does equal 45. Okay, that was 13. Boom, let's take a look at 14. I've got this angle is 150, and I know that this segment is bisecting the 150 right here. There's a couple ways we can write this. We know these are both congruent, so that means that this is also 4x minus 5, right? So you could say 4x minus 5 plus another 4x minus 5 has to add to 150. Okay, that's a good equation. But you could also say, oh, well, if these are both congruent, that means if I cut 150 in half and get 75, I can also just say 4x minus 5 equals 75. That's a good equation too. And they're both will get us the same value for x. So if I take this one and add 5 to both sides, I get 4x equals 80. And divide by 4. Do you see we get 20? And over here, I'll just go ahead and do this one too. If I have my like terms here, I get 8x minus 10 equals 150. Add 10 to both sides. I add 8x equals 160. Divide by 8. 8 goes into 160 20 times. You see, we got the same answer for both, so either way is good. Next one, 15, 70 minus 1. We know this is a 90-degree angle, so simply we just say, well, this angle, 7d minus 1, this expression, has to equal to 90. So solve for d. And you might think, oh, there's no way that 7 goes into 91. But it does. 13 times. So D equals 13. And that one's done. 16. VW is 18. VZ is 1/3 x plus 20. I don't know what this little extra r is here. That's interesting. It's probably just left over from when I made the figure. No, I'm just going to leave it. Okay, so I've got my congruent symbols here. So what is the value of VZ? It's got to be half of 18, right? So this has to be 9, and this has to be 9. So VZ is 1/3 times x plus 2. That must mean that 1/3 times x plus, 20 has to be equal to 9. And then we can solve for x. So we could distribute the 1/3 in here, but the easier way is just to multiply the reciprocal. So I'm going to get rid of the fraction by multiplying by 3. So that cancels. So now I have 27 on the right, and I've got x plus 20. And now if I subtract 20 to both sides, I get 7. Last one of the algebra problems for now. Find x, SR, line SR is the angle bisector of angle UST. Okay, so that means that I can put my congruent symbols here because these two have to be equal angles if this is a bisector. USR is 3x plus 2.5 degrees, and QSU is 25. QSU, that one's already labeled. Okay. I think on this one we know that the measure, so I think a piece of instruction is missing here, so let's add it. So we know the measure of angle QST is 90. So we've got this angle right here we know is 90 degrees. Okay, so there's a couple of ways to do this. I think I'm just going to do the angle addition postulate here. So I'm going to say, I can even just write it out, right? So we got angle TSR is this angle here, this one right here, plus RSV, angle RSV, is this angle here, plus angle USQ, These three angles are all going to add up to be angle TSQ, and that's the 90-degree angle. So we know these all add up to be 90. And let's substitute all the other ones. TSR, well, TSR is congruent to USR, so we know these are both 3x plus 2.5. So let's put 3x plus 2.5 plus 3x plus 2.5 plus this angle right here, 25, equals 90. Let's add these like terms. 3x plus 3x is 6x. 2.5 and 2.5 is 5. Plus 25. equals 90. 5 plus 25 is 30. Subtract 30. 6x equals 60. I'm running out of room. Divide by 6. Boom. Get that over there. X equals 10. If I put 10 in for x here, I would get 3 times 10 plus 2.5. That's 32.5. This would also be 32.5. And if I add 32.5 plus 32.5, that's 65, plus 25 is 90. So that checks. Find the midpoint between each pair of points. Okay, so we know that the midpoint formula tells us to take the average of the x values, the x coordinates. So that means we add both values and divide by 2. That's how we find the average or a mean. And we take the average of the y values. Okay, that's how we find the point in the middle. And so let's label this a point right here. So we're going 1, 2, 3, 4 to the left. So that's a negative 4x value. And we're going up 5. And b, we're going over 6. And we're going up 1. Okay, so I'm going to call my a point the first point. Doesn't matter which point is x1, y1. You just have to be consistent when you plug it in. So I'm going to call this my x2, y2. And now let's substitute everything in. So we have x1, negative 4 plus 6. Negative 4 plus 6 over 2. And then my y values. I've got 5 plus 1 over 2. And negative 4 plus 6 is 2 over 2. 5 plus 1 is 6 over 2. And that gives me 1, 3. So let's find that point. 1, 3. Boom, right there. That's M. That's our midpoint. Now, these 3 points, A, M, and B, are collinear. They better be collinear. They need to share the same line. So if I draw a line through them, now I'll just go all the way across. M better be on there, and it is. And if it's not, it means you made a mistake. So AM, segment AM, is congruent to segment BM. M is the midpoint. Okay, 19. First step, write the equation. That's a good first step. M equals, we take the average of the x values, the average of the y values. Let's label. So we're going, let's see, which one do we want the first? So D comes before E. So we can call this one the first point. So we'll call this one 6, negative 2. So this is my x1 and my y1. And E is negative 2, negative 4. But again, you could change these. Doesn't matter which one is x1, y1, x2, y2. Just got to make sure you plug it in correctly into the equation. So we got 6 is x1 plus negative 2 over 2, comma, y1, okay, negative 2 plus y2 is negative 4. Notice how I'm using parentheses here with my negatives. If it's a negative value, I'll put it in parentheses. 6 plus a negative 2 is 4. So I got 4 over 2. And negative 2 plus a negative 4, that's a negative 2 minus 4 is negative 6 over 2. So I get 2, negative 3 as my midpoint. Negative, so let's go 2, down 3, boom, right there. That's my M. Let's make sure that's on the line. It is. those are congruent. Okay? Find the midpoints between each pair of points A and B algebraically. By the way, up here for these, I said find a graphical solution. And I didn't really go over the graphical solution, but if we have A and B, and maybe it's helpful to draw that line between the two. If I count how many I go down to point B, I'm going down 4, right? So if I take half of 4, that gives me 2. So if I go over to the right horizontally, and then let's count from A to B going in this, well, that's vertical actually, in this horizontal direction. It'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10. And this one I went down 4. Half of 10 is 5. So if I go over 5, 1, 2, 3, 4, 5, and up, it'll run into, these two lines run into each other and show us where the midpoint is. So that's a way we can do it visually, just by counting how many up and over we go. Okay? But I want to rely more on the algebraic way of finding it. Okay, so find the midpoints between each pair. So I've got my midpoint formula. Simplifies to 3, -5. Okay, make sure you write parentheses and a comma like this. This is how we show an ordered pair. Okay, next one. I show all of my steps here so you guys understand problem solving approach. And I think it's a good idea that you do the same, at least until you become pros at this. X1, so we got -4 plus 14 divided by 2. And then we're going to do 10 plus 0 divided by 2. And we get 10 over 2 and 10 over 2. Okay. So we get 5, 5 is our midpoint. Let's do some plum. Last one from this set, and we have a decimal here. It's okay. We'll trust the equation will work out for us. And if we get decimals in our answer, that's okay. So -1.5 plus 3.5 divided by 2. My y1's 2 plus 6 over 2. So -1.5 plus 3.5 is 2. So I get 2 over 2 and 8 over 2. I get 1/4. Is that midpoint? All right, gotta stretch my hand for a second. All right, so 23 and 24, these are very different problems. Okay, we have to be careful here and not just do the same thing that we've been doing. Okay, so let's think about this for a second. Okay, find endpoint B given endpoint A. So let's say I know this is point A right here. Say this is point A. And here's my midpoint. Where is point B going to be? Well, point B is going to be somewhere that's collinear with the other 2 points, and it's going to be the same distance away from M as A is from M. So this distance here has got to be the same distance as over here. So B has got to be over here somewhere, right? So in this problem, I'm giving you point A, and I'm giving you where the midpoint is, and you have to find where the other endpoint is, B. Okay? So there's a couple ways of doing this. So I'm going to show you an algebraic way first. So what we did before here is we used this formula here to find the midpoint. And I'm just going to say that this value right here, that was the x-coordinate for the midpoint. That's what this we found right there was. And then this one was the y-coordinate of the midpoint. I'm calling this a little subscript m right here. Right? So this x midpoint goes with this x value expression. So I can say the x of m midpoints equals x1 plus x2 over 2. And then the y midpoint was just the average of the y values, like we just said, right? Just like this. So now, let's substitute here. Let's label the top here first. So let's call this A as our first point. So that's x1, y1. And the m coordinates here, this is my x for my midpoint. I'm going to call that subscript m, and y sub m. So now let's substitute here. X of m is 8. 8 was the value of the average of the 2 x values. Well, I only know one of the x values. I only know negative 2. I actually don't know what x sub 2 is. So I'm going to just leave it as x sub 2 divided by 2. I do the same thing with y. So my y value is negative 7. That's the midpoint for my y. I know my y1 value is negative 3. I don't know what the other y2 value is. That's what we're looking for. So I've set both of these up. I can now solve for x sub 2 and y sub 2. So here we go. We're gonna solve this. I need to first get rid of this divide 2. Okay? So I'm going to multiply 2 to both sides to get rid of this divide 2. And now I've got 16 over here, negative 2 plus x sub 2. Now I'm going to add 2, and I get 18 is my x sub 2 value. On this side, I'm going to multiply 2 to both sides. That cancels the divide 2 here. And I get negative 7 times 2 is negative 14 equals negative 3 plus y2. Add 3 to both sides. Negative 11 is my y2. So my b coordinate is going to be 18, comma, negative 11. Okay? Now, let's try that with the next problem 24. Let me do the same thing. So, give myself some space here. Okay, so I'm going to write my equation here. My x sub m, my midpoint formula is take the 2 x coordinates and divide by 2. That's the average. Do the same with my y sub m. y sub 1 plus y sub 2 over 2. Let's label my points here. That's my x sub 1 point. This is my y sub 1 point. This is my x coordinate of my midpoint. This is the y coordinate of my midpoint. Now let's substitute it in. X sub m is 14 equals negative 4 plus, I don't know my x sub 2. You know, if I wanted to write it over here, I could. I could say b is x2, y2, right? I don't know what that is. There it is right there. My y sub m, let's go 0 is my y sub m equals y sub 1 is 10 plus y sub 2 divided by 2. Oh, I forgot to divide I got ahead of myself. Don't forget to divide this by 2 over here, right? Okay, so now we're going to multiply both sides by 2. 28 equals negative 4 plus x sub 2. So 32 is my answer here. And then I'm going to multiply both sides by 2 here. 2 times 0 is still 0. Subtract 10. My y sub 2 is negative 10. Put it all together. My b point is 32, comma, negative 10. So, I mean, if we think about this a little bit, let's see here. So, if I have, let's say I have my coordinate grid. Now, we're doing this without graphing, but I'm just helping with a visual here. Negative 410 for the A is up here, right? Something like that. Second quadrant, left 4, up 10. My midpoint is 14, 0. So I'm way over here is my midpoint, right? Now, where would my B point be? It's got to be way down here somewhere, right? On the opposite side of M. B is opposite of the side that A is on, right? Down here. And so look at the point that we ended up with. We ended up getting 32, negative 10. So we're all the way out over here, way over here at 32, and we're going down to negative 10, way down here. This is where our B point is. Does that make sense? Right? So we got, we go a line through here, and then these are congruent, right? Okay. We have our last one here. I think next time we're in class, I will discuss another way to find the solution here. Sorry, x2. That might be a bit easier for a lot of you and is quicker. But it's really good to know how to use the equations and how to manipulate them to get our solutions, to get our answers. So we got x1, y1, and we got x sub m here, and y sub m here. Now let's substitute what we got. 3.5 equals x sub 1, which is negative 1.5, plus x sub 2 divided by 2. Let's get a different color. So 6 equals y sub 1 is 2 plus y2 we don't know, right? Remember, our b value is x2, y2. This is what we're looking for. Now let's solve. Multiply 2 to both sides to get rid of the divide 2. 2 times 3.5 is 7. And then we're going to add 1.5 to 7. 8.5 is my x sub 2 value. We're going to multiply 2 to the right and left side and solve for y2. So my point, when I put it together for B, is going to be 8.5, comma 10. Okay? I hope this makes sense to everybody. I know this gets a little abstract, you know, with all these equations and numbers and everything. Given the figure, find the coordinates for point F. Okay. Tell you what, I'll show you. We could rely on the equation here for this. But maybe I'll show you the other way to approach these problems, especially with this visual one right here, right? So let's think about this. Let's go with the x first. If I'm at 2, 8 here, and my h point, this is my midpoint, is at 7, 6. So if I'm at 2 and I go to 7, how many units is that? If going from 2 to 7, how many units am I going over in this horizontal direction? Isn't it 5, right? I'm going from 2 to 7, that's 5 units. So to get to F, I would need to go 5 more units to get over to F, right? So if I'm at 7 and I go 5 more over, where am I? I'm at 12, because 5 plus 7 is 12, right? So I'm just thinking about if 2 to 7 is 5, that means F has to be another 5 on the x's over. So I'm at 12. Now let's think about this for the y. If I'm at 8 and I go down to 6, right? Because that's where h is, at 6. Maybe I'll do it right over here. I'm at 8 and I go down to 6. I've gone down 2 units. Well, I've got to go down an additional 2 units to get to F over here. So if I'm at 6 and I go down 2 units, where am I? I'm at 4. So my endpoint for F is 12, 4. Look at that. How easy is that? We're just counting and going over. If I wanted to use my formula, it's still going to work. Okay, I'm just going to run through it really quickly here so you can see. My x sub m here was 7. My x sub 1 was 2. And my x sub 2 is what I'm looking for. I multiply 2 to both sides. 14 equals 2 plus x sub 2. Subtract 2 and I get 12. Right? There it is. Boom. 12. Do the same for my y's. My y sub m equals y1 plus y2 over 2. My y sub m is 6 in this case. I got 6 equals, here's 8 is my y sub 1. I'm going to multiply 2 to both sides. I get 12 equals 8 plus y2. I subtract 8 to both sides. I get 4. Boom, right there. Okay. So you see, if we do this with this counting method, it's really easy. But it's good to know how to use the equation. And this last one right here, find and graph the perpendicular bisector of segment GF. Okay, so we need to find the midpoint first, right? Find the midpoint of this segment. And the way we do that is 2 ways. We can use the midpoint formula or we can count. I'm going to count for this one because it's already visual. I'm going from -1 to 7. So that means I'm going 1, 2, 3, 4, 5, 6, 7, 8 units over. So if I go half of 8, that would be 4. So 1, 2, 3, 4. So if I follow that up until I hit my segment, that'll be my midpoint. I can also do this, check it with the vertical. 1, 2, 3, 4, 5, 6. That's 6 units that I'm going up and down. Well, half of 6 is 3. 1, 2, 3. I follow that over. Boom. It's the same point. So here's my point. My midpoint is here. How about some symbols? And now, something new for you guys. Okay? The perpendicular slopes of lines are, so we already talked about parallel slopes are equal, right? But perpendicular slopes are negative, and reciprocal. reciprocal. So that means we change the sign and then we flip the numerator and denominator. So before we can figure out what the perpendicular slope is, we have to identify, well, what is the slope of segment GF? So the slope is, we could use the slope formula or we could do this visually. We are rising 1, 2, 3, 4, 5, 6, and we're running 1, 2, 3, 4, 5, 6, 7, 8, as we determined earlier. So that is 6/8, which equals, we could take 2 out, so that's 3/4. So what would the negative reciprocal of 3/4 be? Well, change the sign, flip the numerator and the denominator. -4/3 is our new slope, okay? Then we're going to go from our midpoint right here and do the slope of -4/3. So I'm going to go down 1, 2, 3, 4, and over 3. 1, 2, 3. Boom, put a point. Down 1, 2, 3, 4, over 1, 2, 3, put a point. Take your straight edge. Let's get a different color. And draw it through those points. Boom, like that. And notice it crosses the y-axis at 5. Well, this is our b value in the slope-intercept form equation. Y equals mx plus b. I already know my slope is -4/3, and I know my b is 5 because that's where it intersects the y-axis. So to put it all together, y equals -4/3 x plus 5 is our equation of the line. This is the equation of the perpendicular bisector of segment GF. Boom, we're done with that section. Guys, we just did some work on that one. Look at that. Looks fantastic. Hope that makes sense for everybody. We'll have opportunities to go over it in class and ask questions and all that. So hope you have a great day, and I'll check you soon.